So here is a problem. The figure shows a liquid being pumped out using a piston of area of cross section 0.9 into 10 power minus 4 meter square. That means the area 1, A1 is given, okay? And the area of the outlet is 18 into 10 power minus 6 meter square. That means the A2 area. If the speed of the motion of the piston speed is given, this is how we push here in this direction, the piston.
Okay.
The speed of the motion of the piston is 1.8 into 10 power minus 2 meter per second. Calculate the speed of the outgoing liquid. What is the speed of the outgoing liquid here? That we have to find. See, the speed of the piston, you can consider it as a V1.
Yeah.
Okay. So with the same speed only here, the water particle travels in this bigger area. But the moment when it enters to the smaller area, here the speed is becoming V2.
Yeah.
It get increased actually because area is decreased, no?
Yeah.
Yeah. So let's see what will be the speed at the outlet. Okay, speed of the water at the outlet. So we can use the equation of continuity. By the equation of continuity, with the equation of continuity, A1 V1 is equal to A2 V2, right? So here I need to find out the V2 then. So V2 will be A1 V1 divided by A2.
Yeah.
So V2, what is the A1 value? The first area 0.9 into 10 power minus 4 into the V1 1.8 into 10 power minus 2 meter per second. So this is what the initial speed, right? V1. Yeah, divided by A2. The second area is given. This is the A2, 18, right? A2 will be the area of the outlet. It is 18 into 10 power minus 6. Yeah. You can see here, this is 10 power minus 4 and here 10 power minus 2. Together it become 10 power minus 6. So denominator also there is a 10 power minus 6. It will be cancelled out. Therefore, the V2 will be 0.9 into 1.8. Numerator, the value 1.62 divided by 18. So we are getting 0.09 meter per second.
Okay.
0.09 meter per second. So this is the speed of the liquid at the outlet.
Okay.
A liquid density 1048 kg per meter cube is flowing steadily in a tube varying cross section.
Okay.
So it is not a uniform. The cross section at the mouth is, this is the area of cross section at the starting point at the mouth, and that at the end is 10 into 10 power minus 6 meter square. Okay. Calculate the difference in pressure for the horizontal flow. If the speed of the flow at the mouth is, okay, speed of the flow is given at the mouth. Okay, let's see the diagram how it will be. So basically it is not a uniform, right?
Yeah.
So I'm taking non-uniform cross section here.
Okay.
Yeah, this way the tube looks like, correct?
Yes, sir.
And here completely the liquids.
Yes, sir.
Liquid flow will be there. So I will call this phase as a A,
Okay.
and this phase I will take it as a N or B. Call it as a B. Okay.
Okay.
The two phases, A and B.
Okay.
So velocity at A. What is the velocity at the mouth? This is the mouth,
Yes, sir.
and this is the end.
Yeah.
What is the velocity at the mouth? It is given 9.8, correct? No?
Yes, sir.
9.8 into 10 power minus 2 meter per second.
Yes.
Area of cross section is how much at the mouth? Area of the cross section here.
1.2 into 10
Yeah,
power.
that I will take it as a small a1. 1.2 into 10 power minus 4 meter square.
Yeah.
And area of cross section at the end, I will take it as a A2.
A2.
Okay, that is 10 into 10 power minus 6 meter square.
Okay.
Okay, now I don't know what is the velocity at the another point. Let it be V2.
A2.
For this situation, no, I can use the equation of continuity.
Yes, sir.
Okay, from equation of continuity,
Yes, sir.
so we know that product of area and velocity will be the constant. So A1 V1 is equal to A2 V2. So let's find out what will be the V2 value here. It is A1 V1 divided by A2.
Yes, sir.
So A1 is 1.2 into 10 power minus 4. V1 9.8 into 10 power minus 2 whole divided by A2 10 into 10 power minus 6. Okay, here 10 power minus 4 and 10 power minus 2, 10 power minus 6 only. Both the terms will be cancelled here. And solve it further. We get 1.2 into 9.8 divided by 10. So we get around 1.176 meter per second.
Yes, sir.
Okay, the V2 will be the another end. The speed of the fluid, the speed of the liquid will be 1.176 meter per second. Okay, which is quite higher than compared to the mouth. At the mouth, you can consider it as a 0.098.
Yeah.
Yeah. Okay, now we found the V2, but what is the question is? We have to calculate the pressure difference, correct? No, for the horizontal flow. So pressure difference we have to find out. So according to the Bernoulli's principle, see, let us say the pressure at this point is P1 and at this point is the P2.
Yes, sir.
Okay.
Yeah.
So now from Bernoulli's theorem, we know the Bernoulli's theorem that kinetic energy per unit mass, pressure energy per unit mass, and potential energy per unit mass, that will be the constant throughout the flow, right? So I can apply that concept for both the end. From Bernoulli's principle, I can write here that the P1 plus rho g H1 plus half rho V1 square. This is for the one end. And for the other end, P2 plus rho g H2 plus half rho into V2 square. I'm not taking rho 1 and rho 2 because the same fluid is keep flowing inside that. And the condition says that it is a horizontal flow. Correct, no? So the pipe will be at the same horizontal line. Okay,
Yeah.
horizontal floor.
Yeah.
For horizontal flow, there is no height difference.
Yes, sir.
H1 can be equal to H2, both the side.
Yeah.
Okay, see if H1 and H2 values both are same, then this side also rho GH and rho GH can be cancelled,
Okay, sir.
right?
Yeah.
And what the left out term? So we left out with P1 plus half rho V1 square P2 plus half rho V2 square. Now we have to find out the pressure difference. So that pressure difference, take this P2 to the left hand side and send this half rho V1 square to right hand side.
Yes, sir.
So P1 minus P2 is equal to half into rho V2 square minus half
Yes, sir.
rho V1 square. So I can take half into rho common.
Yes, sir.
Yeah, take it common out. Then V2 square minus V1 square.
Square.
Yeah, this is what the pressure difference we have to find. Yeah, let's find out now. Half into rho value, the density, it is given 1048. V2 square, the V2 just now we found out that is 1.176, the whole square, minus V1 square, 0.098, the whole square.
Okay.
Okay.
Yeah.
So solve it further. So half 1048 divided by 2 you can take. So it becomes 524. And here this you can solve it like a plus b into a minus b. It look like a square minus b square.
Oh.
Okay, so you can take like a plus b into a minus b.
Okay.
Yeah. So by using this method, you can avoid doing the square for each term.
Oh,
I did the a plus b into a minus b now, minus 0.098. Okay. On further calculation, yes. Let's add 1.176 plus 0.098. So we get 1.274. And 1.176 minus 0.098. It is 1.078. Let's multiply it further. 1.274 into 1.078 into 524. So we are getting 719.64 Newton per meter square.
Yeah.
So this is the pressure difference across the pipe. And this is the problem. Tap has an area of cross section. Area of cross section of the tap is given. Correct, no? 10 power minus 5 meter square. You
Yeah.
can just take it as a A1. 10 power minus 5 meter square. Through which water comes out with initial speed. Initial speed is given. Let it be the V1. Okay, that is 1 meter per second. Assuming steady flow means the speed remains constant. Okay, right? So, and the pressure to remain constant
Yes.
at all the points. What is the area of cross sectional of the stream? 0.4 meter below the tap. Mhm. So below the tap, we should find out first. So, but here we doesn't know what is the speed of water 0.4 meter below the tap.
Yes, sir.
Okay. So here is a tap. So this is a tap here. Area of cross section of the tap is given. Okay.
Yes, sir.
Through which water comes out with a speed that is also given. This one I taken as a A1 and the speed, whatever the water falls here, that I took it as a V1.
Okay.
Assuming steady flow and the pressure to remain constant at all points. So here completely the steady flow will be there. Okay. What is the cross-sectional area of the stream? 0.4 meter below the tap. Okay.
Yes, sir.
Below the tap here. 0.4 meter below.
Yes, sir.
So the water keep flowing right here. So what will be the area of the stream? Area of the stream. Okay, this area. So A2 you should find out. But I don't know what is V2 here, right?
Yes, sir. V2.
V2 and A2. Let's find out the both now.
Yeah.
Okay. So since it is in motion, every particles are in motion when you turn on the tap. Okay. You can use, and it's a uniform motion, this is steady flow, right?
Yes.
Okay. From the equations of motion, we can use this formula. V square minus U square is equal to 2AS, right? But here it is falling under the action of gravity. So I can use this term as a V2 square minus U square is equal to 2GS. Okay. From this, I can write it as a V2 is equal to U square plus 2GS.
Okay.
Then P2 is equal to, so U square is nothing but the initial speed. Okay. This V1 itself is the U, that is 1 meter per second.
Okay.
So this is a 1 square plus 2 into G acceleration due to gravity. So roughly I will take it as a 10. And S value it is given. This is the distance, right? 0.4 meter below they said.
Yeah.
So that is 0.4. So under the square root is a 1 square means it is a 1 only.
1. Okay.
Therefore V2 will be, yeah, how much you get here? Calculate. 2 into 10, 20, 20 into 0.4. So we are getting 8 and plus 1.
Okay.
So total it is root 9, that is a 3. So V2 is 3 meter per second.
Oh, okay.
Speed has increased here.
Okay.
Right. So therefore, now I can use the equation of continuity.
Yeah.
V1 is equal to A2 V2. What I should find here? A2, right? Therefore, A2 will become A1 V1 divided by the V2. Substitute all the values. 10 power minus 5 into V1 divided by V2. V2 is 3. Okay. The area of cross section
Yes, sir.
of the stream is 1 over 3.
Okay, sir.
So that means 0.333, you can say.
Okay.
Correct, right? Into 10 power minus 5 meter square.
Okay.